Hi everyone, my name is Dr. Tilina Surasinghe. I'm a professor from Bridgewater State University in Massachusetts, United States. And today I'm going to talk about a multi-partner collaborative project that we conducted regarding Sri Lanka's forest cover dynamics, particularly focusing on Sri Lanka, and then subsequently moving on to understanding the drivers and the patterns of this forest cover change, and then discussing about how that our research can provide insights onto environmental policies in Sri Lanka. And I do want to emphasize that this project was handled through multiple institutional partnerships, including partners from Sri Lanka, um, and several other institutes across the world. I know it's kind of a cross-continental study, but focused on Sri Lanka. So, first of all, there is a global scale observations on global scale changes in forest cover, right? I mean, so that's largely that kind of forest cover change is driven by overwhelmingly by deforestation, um, which tantamounts to a net. This is evident through deforestation occurring in mostly in the tropical realms. So tropical rainforests, monsoon-based dry seasonal tropical forests, among um, a couple of examples that I can provide to you as kind of the forest types that are suffering disproportionately from deforestation. And then that has been also evident through certain parts of the deciduous forests in the temperate zone. Um, so what is driving these kind of forest losses? Or deforestation. Largely, the causes are anthropogenic, right? This involves clearing forests for agriculture, urban development, urbanization, different types of human settlements, for industrial development. There's a huge competition between anthropogenic motives and conservation motives, and when these two collide most often, the anthropogenic demands shadows the conservation needs. I must mention there are certain natural disasters like forest fires, that has also led to substantial forest cover loss, and some of those. I must also caution in that sense that particularly in the northern hemisphere, particularly in North America and to a certain extent in Europe, the temperate forests are fire adapted. They adapted to different frequencies of fire, right? But we are aware that with the climate change and other um, global change phenomena, we are experiencing an unprecedented rate of natural disasters like forest fire, which has substantially increased the modifications of the forest cover, and particularly if you think about certain cases like the forest fires in Brazil in the Amazon basin, those are actually unnatural events of forest fires or natural destructions that are substantially responsible for loss of forest cover or changes in the forest cover. There has been global scale interests in studying these patterns of forest cover change at different parts of the world. This can be taken back to the Millennium Ecosystem Assessment, one of the most comprehensive studies that are worldwide that assessed the global scale loss of forest cover. That project estimated about 3% of forest cover losses from 1990s to 2015. Now that sounds like very modest in terms of forest loss, but if you try to look into the statistics and try to calculate how much of that how much of the natural forest cover has been lost, that's about 6%, right? So actually a loss of more virgin or least disturbed forest cover is much higher than that 3% figure that you might be familiar with from literature. So um, there are lots of studies that actually have studied forest cover on different temporal and spatial scales, but those studies carry certain limitations. Um, So most of the studies that is out there's a lot of studies, by the way. Those are actually, global scale or continental scale or at ecoregions, done across ecoregions that spans across continents. So current studies are very spatially extensive, and as a result, the resolution of these studies, at spatial scale, are pretty coarse because you cannot, it's sort of infeasible to study global scale forest cover change phenomena while keeping a greater resolution. It's kind of computationally intensive, and takes a long time because of that reason. Um, there are a few studies done at country level, right? So which actually, brings in another problem. In certain countries have a greater representation of study forest cover changes. For example, in North America, in the United States, there's a lot of studies that looks into different aspects of changes in the forest cover, starting from like the spatial scales changes to even changes in the structural scale, looking into the biomass changes and stuff like that. So, but there is actually still gaps in certain countries that haven't even been adequately studied, like in Sri Lanka, for example, like we are going to get to. There's very little focus on studying what's going on in Sri Lankan forest cover changes. And that kind of, there are reasons why there are, why fewer studies have been done in countries like Sri Lanka. Basically, they don't have enough basic information, data, in order to set up a study like that. But the problem is, in countries where you observe the least amount of studies are the countries that are richest in biodiversity, like Sri Lanka. So that is a problem because it actually, if you don't know the dynamics of the forest cover, which actually is one of the biggest conservation, one of the greatest resources, that is the foresight of conservation, lack of that studies lead to impediments, hindrance to conservation actions and for sound science-based natural resource management. So, what do we know about forest cover changes in Sri Lanka, right? Why is it important to study that topic in Sri Lanka? Sri Lanka, if you look at the history, there's a long history of Sri Lanka, documented history of Sri Lanka, that have undergone multiple land cover transitions, which actually dates back way beyond the European colonization. So in general, there's a lot of generalized literature information that we could put together that says, plantation-based agriculture and slash and burn farming are the two key forms of farming practices that is responsible for forest cover change. And then more also in the recent decades, it's actually the rural resettlement programs and then these export-based developmental industries that are also responsible for massive amount of forest cover change. And then there's an interesting story that we came up with. Well, actually, we read through several sources of literature that actually discusses the impacts of the ancient civilizations in Sri Lanka that may have actually triggered a lot of massive changes in forest cover since the imperial era. Before the European settlements, European invasions. So, in general, if you look at the past 100 years, with combining certain studies, you can actually come to a very reasonable conclusion that there is the overall trend across the country is not only declining forest cover in general, but increasing rates of deforestation, right? So by 1956, we have about, nearly half of the country had forests. Of course, they are of different successional stages, but, have nearly slightly less than half of the country had forests. By 80s, that dropped below 40%. By early 1990s, well, dropped to a third, right? And today, right, it's actually, by 2010, about 10 years ago, right, where we actually have some data from, the forest cover is actually significantly less than a third. So there's some anecdotal evidence suggesting it could have been as much as low as 20% in the modern day. Well, so we do need an update of, forest cover change in the current decade, right? And we need to use contemporary data and most contemporary statistical and computational method to do that assessment. And that will help us to understand subsequently the patterns of forest cover change, the extent of forest cover change, and understand where it is happening. So in this study, our overarching goal, our aim is to study the forest cover dynamics, right, in Sri Lanka with a particular focus on the dry zone, right? And so we wanted to produce a forest cover map for 2019, right, the year before, and then do some sort of a comparative analysis across the space and time to understand how forest cover changes from 1992 to 2019, and then subsequently determine what are the drivers of these forest cover changes. So our study area is the dry zone of Sri Lanka. As you can see in this particular map, the pink color represents the dry zone, right? And for those conference attendees, we are looking at an international conference. So I assume some of you, most of you are familiar with where the Sri Lanka is, but here, it's a perspective of where Sri Lanka is within South Asian realm. So, nearly 60% of Sri Lanka's total land area is located within the dry zone, and in that zone, you find a huge monsoon wind influence. So the rains are driven by monsoons. You do recognize about 4 different forest types. This is based on literature. Some forest biologists may argue against some of these categories, but that's not the point of our presentation. Generally, you can recognize at least these 4 different types. Generally, the topography of the lowlands are dry zones. You get some undulating hills plus a few significant extent of residual hills speckling the landscape of the dry zone. It's a tropical country, tropical island, Sri Lanka. This dry zone's climate can be characterized as dry, humid, warm tropical climate. Mean annual precipitation is slightly under 2000 millimeters. It's on average about 1500, and with a very significantly high evapotranspiration, right? But the evapotranspiration is below the precipitation, and relatively high and stable annual temperature, about 30 degrees Celsius. Now, the methods we include, this is quite technical, and I do encourage you guys to read the paper we published. I will put a link to the paper at the end of this presentation. So the methods we use first include pre-preparation, kind of getting things together using Google Earth Engine, which is actually a free open access geospatial analytical software that actually we used for this particular study for data acquisition and pre-processing. And we used as a data source, we used Landsat imagery, which is relatively good in resolution for very extensive landscape that we are studying, and we relied on 2019 imagery because we are trying to develop a map for 2019, right? And then of course we underwent developing cloud masks, because in Sri Lanka there's a huge cloud cover, nearly almost every time. So we needed to apply corrections for that, and then extract multispectral bands subsequently. So, and then forest cover classification took after the initial pre-processing and data extraction step, which actually included creating about 3 different supervised machine learning algorithms that include support vector machines, random forests, and then we ran all of those different machine learning algorithms on Landsat 8 data that we extracted, and then we developed the land cover types. And remember, this is a binary classification, whether it's forested or non-forests. We were not looking into different forest types, right? And after we have the product from the machine learning setup, we actually did an accuracy assessment based on different metrics. And if the accuracy assessment is greater than 80%, we actually stopped any further analysis and we moved on to the next step. But if the accuracy assessment is lower, we kind of retrained that data and retuned our machine learning classification methods until we reach 80% accuracy, right? And ultimately with that, we produced the forest cover map for 2019. And then the third step is actually include further pipelining the data. and kind of then comparing and contrasting with other standard GIS data sources and data formats. So we have the forest cover map for 2019, right? And then we already have obtained maps for from 1992, 1999 to 2010. So those maps have been already developed by our forest department with collaboration with other organizations. And then we calculated the forest cover changes from 1992 to 1999, 1999 to 2010, 2010 to 2019, right? And calculate the overall changes in the forest cover. And then we even looked into these forest cover changes in different administrative districts. We are not going to go into that far today. And then we also looked into this forest cover change within inside protected areas and outside protected areas. That I will talk about a little bit. Now, let's look at what's going on with forest cover changes in dry zone here for a little bit.